Thanks for joining me in today's lesson. In this tutorial, we will use the z-score table to find percentiles and z-scores, and we will use the z-score percentiles to find specific data points. So we are in our final section of 11.3, z-score percentiles, and before we begin with that and how to read the table that I've given you, I'd like to recall some of the definitions. We have standard deviation, that's our sigma. This is the distance away from the mean. We have z-scores, that's just labeled as a z. That is the measure of how many standard deviations we are away from the mean. And of course, we have our z-score formula. This will be given to you on our state test, of course. X minus mu divided by sigma. X is your data point, mu is your mean, and sigma is your standard deviation. So we can use that to calculate any z-scores. The first thing I'd like to do in this tutorial is get familiar with the z-score percentile table that I've given you. So if you could please get that out. I'd like to make sure that you know which side has the positive z-scores. And in this case, pull up the z-score table here. You should see the word positive on one side. So go ahead and understand that those are the positive z-scores. And my second question, which side has the negative z-scores? Well, obviously, if you flip your piece of paper over, you're going to have the negative ones. I'm going to scroll down, and you'll see on the other side, of course, the word negative says that we have our negative z-scores. Okay, next, can you find the z-score of 1.25? So we're looking for the z-score for 1.25. Obviously, since that's positive, I'm going to go off the negative page and go to the positive page. Understand how to read this table. First, we go down this column, and we're looking for a z-score of 1.25. Well, the first thing I'm going to go to is 1.2. So we're looking in this row, and we have 10 different probabilities that are in this row. 1.25, I have to go all the way over until I get to the fifth one, which is right here, 1.25. So that is right here. I'll highlight it on mine. Maybe you circle it or something. This is the probability of 0.8944. So that's how you find a z-score of 1.25. Go to the 1.2, and then go to the 0.05, and then together that brings us to this cell in our chart. My next question, can you find the z-score of negative 2.88? So let's go back to our chart. Obviously, we're talking about a negative z-score, so I'll flip over to the negative side. Negative 2.88. I'm going to start now. This kind of goes backwards. It's going down here. Negative 2.88. Oh, negative 2.8 is right here. And then watch across the top. It actually starts at 0.09 and goes down. So if I'm looking for negative 2.88, we're talking right here, 0.0020. So that's how you read this chart. So our final question, can you find which z-score has a probability of 0.7389? So this is kind of going backwards. Instead of giving you the z-score and you tell me the percentage, this time I'm giving you the probability, I'm giving you basically the percentage, and you tell me what the z-score is. So we need to find which cell in our table is 0.7389. So let's go to our table and see if we can find that. You can see on this negative side that the probabilities are increasing all the way. As I go down this, they're getting bigger and bigger and bigger all the way. The biggest one on the negative side is exactly 0.5, which hopefully that makes sense because that's a z-score of 0.00. That's right there in the middle of our data, so it makes sense that 50% would be on this negative side. Since that's not even big enough, we're trying to get to 0.7389. Let's see if we can find it on the positive side. So I'm looking, I see the 60s, and here's the 70s, 0.7. Oh, I found it. 0.7389. So there's the cell that has that. Now I need to figure out what the z-score is. 0.6, and then above this is 0.04. So together that makes 0.64. And that is the z-score that would correspond to this. The z-score for this is 0.064. So let's look at our first example. Example 1. Suppose we look at the normally distributed scores for the SAT. If 45,000 students took the exam with a mean of 1550 and a standard deviation of 250, then we have all of these questions. First, let's label our normal curve. Let's put right here in the middle our mean, which was 1550. So that's the average score on this SAT. And it says the standard deviation is 250. So we need to start adding, I'll put the mean right here. Well, let's start adding the standard deviation. So if I add that, I'll get 1800, and then add 250 again, I'll get 2050. Then add 250 again, I'll get 2300. Very close to a perfect score. Let's look at below the mean, below the average. If I start subtracting 250, I'll have 1300. Subtract again, I'll have 1050. And subtract again, I'll have an 800, and of course we don't want to be down here. So that's just labeling our normal curve at this point. So now let's start answering some questions. Part A, how can we determine in what percentile a student who scored an 1800 ranked? So we need to figure out the z-score. To be able to use the z-score table, we need to find the z-score. So our z-score is going to be our data point, which in this case is 1800. We'll subtract the mean, which is 1550, and we'll divide by the standard deviation, which is 250. This z-score, if you plug this into your calculator, is exactly 1.00. That's actually exactly, oh, I see the 1800 right here in our work, in our normal curve. It's exactly one standard deviation above the mean. So if we wanted to figure out what percentile that would be, we need to now go to our table and find where the z-score of 1.00 is. So I'll go to my table. I know we're talking about positive. Here's 1.0, and then let's go see where the top is. Oh, here's the 0. 1.00 is right here, 0.8413. So this corresponds to 0.8413. Now this is the probability. Probabilities are measured out of 1. If we want a percentage, then of course we would multiply by 100 and we'd have 84.13%. And that's what we're talking about, 84.13%. So what that means is somebody who scores an 1800 on the SAT, at least given this data, scores better than 84% of the people that took it. So that's not too bad. Part B, similar question. How about a 1400? Now we know that 1400 is going to be somewhere down here. It's a little bit below the average. So we know it's going to have a negative z-score, but that's what we need to find first. We need to find the z-score. So we'll take 1400, we'll take away our mean of 1550, and we'll divide by our standard deviation of 250. This z-score, when you plug that into your calculator, gives you a z-score of negative 0.6. You could say negative 0.60 if you want to. That's what we need to go and look on the chart, negative 0.60. So if I go to my chart, obviously I need to go into the negative area this time. Negative 0.60. Okay, so I see the negative 0.6. Now if I look way up at the top, which I can't see right now, so let's do this. Don't forget, this is where 0.09 is. The 0 is all the way down here, so it's sort of backwards on the negative side. So we're looking at the far right cell. Oops, let's go this way. So negative 0.60 is all the way right here, which is 0.2743. So I'll say that this corresponds to 0.2743. Move my decimal point 2 units, and I've got 27.43%. So if we're looking for the percentage, then we're talking somebody who scores a 1400 does better than about 27% of the people that took the test. Not as good. So let's look at Part C. Part C says, what percent of students scored between a 1400 and 1800? Well, since we just figured out the percentage of students that scored the 1800 and the percentage that just scored the 1400, we can simply take those two percentages and subtract them. Of course, I'll take the bigger one minus the smaller one, 27.43, and when I subtract those, I will have the percent of how many people scored in between those two amounts, so 56.7%. So that's not too bad if we're looking for the percent that scored between two certain scores. Find the z-score for each one, equate those z-scores using your table to the percentage for each one, and then simply subtract the two percentages. And there we go. As opposed to part D, where I'm looking for how many students scored better than a certain value, a 1600 in this case. This time we're not looking for a percentage, we're looking for how many actual students out of the 45,000. We're going to need the percentage first, and then we'll multiply that percentage to the 45,000. So the first thing I should do is deal with this 1600. We haven't found that z-score yet, so let's do that. We've got 1600. Usually this is always the first step to find the z-score. Take away the mean, 1550, divide by the standard deviation, 250. This z-score gives me a z-score of 0.2. Do that in the calculator, you get 0.2. You could do 0.20 if you wish. And now we need to figure out what z-score or what percentile gives that z-score. So let's go to our table. And 0.20, here we go. Here's 0.2, and then across the top I see the 0, so 0.20 gives me the 0.5793. 0.5793. So this, using the table, equates to 0.5793, or if I move the decimal point, we're talking about 57.93%. Now let's understand what this number means. If we're looking at our normal curve, and we're talking about a z-score of 0.2, if this is right here in the middle, and let's just say that this is the first standard deviation, a z-score of 0.2, I guess, is approximately right here. What that's saying is that we have scored better than 57.93%. This is all the people that we've beaten, basically, on this test. But what's this question asking? How many students scored better than 1600? So we're not talking about that 56%, or excuse me, 57%. We're talking about the rest. These are the people that did better. So how do we figure that out? Well, let's take our 100%, everybody that took it, and subtract the 57.93%. When we subtract that, we're talking about 42.07%. That's the percentage of people that scored better than a 1600. The table is always going to give you the value of people that you've beaten, the percentage of people that are below what you did. If we're looking on the other side and pay attention to the directions, if we're looking for people that scored better than that, then we need to subtract that number from the chart from 100%. So we're talking about 42.07%. Okay, so now if we actually need the actual value, let's go over here and say, okay, equate it back to the actual decimal, 0.4207 times the 45,000 students who took this, and when we do that math, we get 18,931.5. Now, obviously, we're not going to be talking about half a student, so let's just get rid of that. We'll talk about 18,931 students, and that's the answer to this one. So that's a tricky problem. You got to watch out for which side of our normal curve are we on. Okay, the last two for this one, let's look at this. What score is in the 68th percentile? So this type of question is going backwards. Instead of giving you a score and you go and find the percentage, I'm giving you the percentage and you need to go backwards and find the score. So let's go to our chart first and figure out where the 68th percentile would be. I'm going to pull up the chart and let's see how close we can get to the 68th. I see 66 and oh, there's 70, so there's 69, 68. Here we go. Okay, so there are two that kind of surround 68. We've got 0.6772 and 0.6808. Now, which one of these is actually closer to 68? Well, this is only 8/10,000ths away from the 0.68, and this is actually 28. So 0.6808 is closer. We're just going to use the table to get as close as we can, but please understand that this one is a little bit too low. It takes us 28/10,000ths to get back up to 6.68. This one is only 10,000ths off. So 0.6808 is the winner. So we're talking about 0.6808 from the table, from the chart. And what is that z-score? Well, let's go back to the chart and figure that. Oops, here we go. So 0.6, this is the one we're using. And what is that z-score? That says 0.47. 0.47. So that's our z-score. 0.47. So since we have our z-score, we know that that's going to be equal to our test score, which I don't know. That's just our data point that we're looking for, x, minus the 1550 divided by the 250. And this is our equation that we need to solve. So if I'm looking for x, I'm going to get rid of this 250. Let's go ahead and multiply by 250. And I'm going to take this x minus 1550. I'll put that on the left side. 250 times 0.47 is 117.5. And then let's add our 1550 to both sides to solve for x. And we'll have our x, which is our data point, the test value that we're looking for, 1667, 0.5. I guess we're either scoring at 1667 or 1668, but that's the value that would be in the 68th percentile. So we're just going backwards. We're using the process and going backwards. Let's do one more. What score is in the 90th percentile? Okay, the 90th percentile, we have to go back to our table, and let's see if we can go find what's closest to 90. And I'm looking, I see 90, 90, there's 90, there's, okay, I found the two that are surrounding the 90. I've got 0.8997, that is very close, and 0.9015. Well, this is 15/10,000ths away, and this is only 3/10,000ths. So it looks like we have our winner, 0.8997. So we're talking about 0.8997. Again, that's just from the table, from the chart. And what is that z-score? Let's go figure that out. We've got 1.2, and above that is 0.8. So 1.28 is what we're talking about. That's the z-score of 1.28. And that's going to be equal to our formula, which is x minus 1550 divided by 250. And now we just need to solve this, and we did that before. Let's subtract 250, excuse me, let's multiply 250. Now I'm going to take the x minus the 1550 and put it on the left side. I just like my variable to be on the left side. 250 times 1.28 gives me 320. And lastly, let's add our 1550 to get x all by itself. And it looks like we need to score an 1870. An 1870 on this SAT would be in the 90th percentile. So that's a good problem when we looked at a bunch of different parts of it. Looking at example 2, it says the useful life of a radial tire is normally distributed, again, there's our buzzwords, it's nice to know, with a mean of 30,000 miles and a standard deviation of 5,000 miles. The company makes 10,000 tires per month. It says if a radial tire is purchased at random, what percentage, It's good to know that we're looking for a percentage of time. Will it last between 20,000 and 35,000 miles? So it looks like that SAT question where it's a percentage between two different things. So it looks like we're going to find two different z-scores first. Let's talk about the 20,000. So the z-score for 20,000, we'll put 20,000 minus, now my mean was 30,000, divided by my standard deviation, which was 5,000. So that z-score becomes -2. I'll put 0.00. Now we need to figure out what percent from our chart goes to the -2.00. So let's go to the negative side of our chart. There we go. -2.0 is here, and then remember it's backwards across the top. We have to go all the way to this last cell. So -2.00 would be right here, 0.0228. So this corresponds to 0.0228, and as a percentage, that's 2.28%. So what we're saying is that only about 2% of tires are last less than 20,000 miles. Okay, great. Now let's do the same thing, but with 35,000 miles. So a different z-score. Z-score is going to be 35,000. Take away our 30,000, which is our mean, divided by our 5,000, which is our standard deviation. Doing this math in our calculator, actually that's not too difficult, I can do that in my head, it's 1.00. So there's our z-score there. Let's correspond that using our chart. In fact, I think we've already done that for 1.00. 1.00 is right here, 8493. 0.8413. Is that what it was? 0.8413, yes. And that, of course, is an 84.13%. So we're looking for the percentage of time where they'll last in between these two things. So what we need to do is just subtract. We're going to subtract these two percentages, and we'll have our final answer. So 84.13% take away 2.28% is 81.85%, and there's our final answer. Great. And our final question, example 3. The weights of eggs produced on a farm are normally distributed. Again, good to know. We can use our chart. With a mean of 1.4 ounces and a standard deviation of 0.4 ounces. To be graded as an extra large egg, the egg must weigh at least 2 ounces. What percentage of time, again we're looking for a percent, what percentage of time will an egg from this farm be graded as an extra large egg? Okay, so we're talking about one data value, which is this 2 ounces. So let's go and figure out what its z-score is. 2 ounces, take away our mean, which was 1.4 ounces, divided by our standard deviation, which is 0.4 ounces. Subtract this and do this in the calculator. Again, if you're going to do it all in one step, I encourage you to use your parentheses, otherwise you will not get the correct answer. When you do that, you get a z-score of 1.5. You can say 1.50, that's fine. Let's go to the chart and see what that means. 1.50, oh, here we are. 1.5, and the 0 is right there in the first one. 1.50 is right here. 93.32. So this corresponds to 0.9332. And that, of course, is 93.32%. So the question is this the answer? Are 93% of the eggs from this farm going to be graded as extra large? Let's think about this again. Here's a picture of our normal curve. Here's all the eggs. Here's our mean, right here in the middle. A z-score of 1.5 would be, here's 1, here's 2, here's our abnormal 3. 1.5 is about right here. So what did we just find? We just found that 93% of our eggs are this, all of these regions. Are these graded as extra large? No. An extra large egg has to be at least 2 ounces, which means it needs to be on the other side. We're talking about the extra large eggs, not the ones that are less than 2 ounces, the ones that are greater than 2 ounces. So we're talking about this percentage. We need to take our 100%, all of our eggs, and subtract the 93.32%. We're talking only about 6.68% of eggs. So this farm does not typically produce extra large graded eggs. So again, you have to watch out for which side of your value you're looking for. From the chart, you're always given the value that you're beating, beating the eggs. That's hilarious. Again, from the chart, you're given the value that is the stuff that's below where you are. If you're talking about above, where you're talking about extra large greater than that, you have to subtract from 100 and you'll have your final answer. So that's it for our z-score percentiles and getting to know that chart, and we'll practice this more in class. I'll see you then. Bye-bye.